Alright, hello everyone, I'm John Renner.
Hi, John.
Probably don't.
Hi, John.
Thank you. Thank you. Really. And today I'm going to talk about ECMAScript 6.
Hi, John.
Hi, Benjamin. Now, you may not all know what ECMAScript is, and it sounds like somewhere halfway between a skin disease and a programming language. And we'll get to that. So just a quick timeline, because timelines are cool.
Can you go loud?
In 1990, oh, I could allow, okay. In 1995,
Can you also center it?
You also
okay. In 1995, Netscape released Netscape Navigator 2.0. It was really a stunning creation at the time, and it was the first browser to support something called JavaScript. But before it was actually released, it was called LiveScript, up until the very end, when it just so happened that Netscape Navigator also supported Java applets and things like that in the web page, and so they decided to go up against Microsoft's Visual Basic, Visual C++ stuff, and say instead, let's do JavaScript and Java, and we'll tie them together, and everyone will think that, wow, Java's cool, so JavaScript must be cool. Yeah. So in 1996, Microsoft was like, let's get on this JavaScript bandwagon. Except they didn't own the copyright to JavaScript, so they created JScript. Many people think it's different, but it's really not. It's exactly the same thing, different name for copyright reasons. And this is IE 3.0 where this showed up. Then in 1997, basically everyone came together and was like, okay, this is silly, we're all using this language, we should come up with a standard for it that's not controlled by any one given person, because, for example, HTML is controlled by W3C, you have committees to help handle these things. So ECMA International, which is a standardization organization, they also, for example, standardize C#. Standardized language under the spec ECMA6, the catchiest of languages. And it was given the name ECMAScript, which is absolutely terrible, but the cool thing is no one really owns the trademark to it, so everyone can use it. So that's exciting. Over the years, ECMAScript developed up to 3.0, and then there was this huge project in the mid-2000s called ECMAScript 4.0. Obviously, they want to keep iterating, and they wanted to put a lot of things in the language. Notice how none of these are actually in JavaScript. We don't have classes, we don't have modules, we don't have generators, we don't have destructuring assignment, algebraic data types, or optional types. Nothing. So, some of you may also know that we're on ECMAScript 5.0. So what happened to all of this? ECMAScript 3.1 became 5.0. We skipped over 4.0 and just said, okay, this minor addition to 3.0 is now 5.0. Because 4.0 is apparently too hotly debated, they decided to just play it safe and do basically nothing. So, thankfully, we're now moving past 5.0 into 6.0. So everybody get excited.
Yay!
Thank you. Thank you. Alright, so here's what's coming in this one. Notice most of this list is the same as what was in 4.0. But we've also lost a couple of things. We've lost optional data types. We're staying in a scripting language. And we've lost algebraic data types because if I say that, do you even know what I mean?
Yes.
Well, go. So, but we see some extra things here which we'll get to in a little bit. Quick disclaimer, this is all based off of the current draft of the spec as of January 20th, 2012, 2014, which is the 22nd revision, and we should be seeing a final release around December of this year. So things could change between now and then, but most of it's pretty solid. So we're going to start with the simple stuff, the syntactic sugar, the little bits and stuff we got to make life easier for us. Fat arrow functions, also known as rocket syntax from Ruby. Essentially, rather than having to write the whole word function out and write a block, we can do very simple functions in terms of just, we put the parameters, an arrow with an equal sign, and then the return value. And you can actually even do full blocks inside of it. It's a small thing, but it saves us from writing function a bajillion times. There's actually a small caveat with this in that these actually do have a slightly different behavior from the old functions, in that, if those of you remember this in JavaScript, if you don't know about it, don't worry, it's only confusing. But this inside these is lexically scoped. So it'll bubble up until it finds something with a true scope. So you can, it's a lot easier, it makes life simpler. Don't worry. Alright, destructuring is really kind of cool. Basically all we can do is we can say math, which is an object that holds a bunch of functions and stuff for us. We can load out attributes of it into variables. So sine is one of the values in there. It's a function. I load it straight into sine in my scope. Cosine loaded into my scope. I don't like the fact that their pi is capitalized as a constant, so I just loaded it into my local pi as lowercase. Did some calculations. It's very exciting. You may also notice that JavaScript does not have precision math. Yeah. So, some of these I've already executed. I apologize. But anyway, so we also get some updates to the object literal syntax, specifically to handle two things. One, programmatic keys. Before in JavaScript, if you wanted to put a key in an object that was programmatically determined, you had to add it after the object was created, because you were only allowed to have strings or things that we converted directly to strings on this side. So now you can put brackets around it and insert a value into a key, and you can declare methods like this. So rather than having to write the word, make the act the key and function the value, we can just write them like that. It's very exciting. We execute it, and we get that output down there. It's very exciting. All right. So, skipping forward. Now I get on to things that are like actually somewhat substantive. Block scoping. So, can anyone tell me what this is going to run? This is current JavaScript. What? Oh, damn it! It's already up there.
I was gonna say 10. Take time and remove the outputs to make this fun.
There we go. Well, what's it gonna be? It's gonna be 10 and 10. And why the hell is it doing that? It's doing that because JavaScript is more or less lexically scoped. So what happens is when I create these functions, they just store a reference to I. And so when I call them, they're calling back up, they're looking for I up the stack, and they happen to find that after we're done with the for loop, I is 10, and so it's 10 in both of those, which is really not what you would want to happen in almost any circumstance. So let me introduce you to the let keyword. Now when we run it, we'll actually get the values we expect. If you'll notice that we're using the fat arrow syntax here, but it does the same thing, just a function that returns I, and we declared I with a let statement. What that means is that that I variable only exists inside this block. So every iteration of the for loop, it produces a new variable that can be scoped up to. So this I will find the I at that run iteration every time, so we don't have to worry about things breaking. Alongside the let keyword, we get the const keyword. You get constant values. It's exciting, I guess. It's also block scope. JavaScript has always had this problem with string manipulation in the past. It's really just been bad at it. So part of it is this new syntax for template literals. Template literals basically allow you to insert values into strings. It's basic interpolation in this case, but it can do a bit more than that. Template literals can also be multi-line strings. So you can just put a new line in it and whatever, it keeps going. They're denoted by backticks. And you can also do something really cool where if I had a function that could process it, for example, this is part of the JavaScript spec on top of HTML, on top of ECMA6. I can say like safe HTML right there, and it would process that as well. Sadly, that function doesn't exist currently, so that won't help me. I'm sorry, Dave, but it could do that. So symbols in JavaScript are, ECMA6, sorry, it's not technically JavaScript, are not what you'd expect. They're not Ruby-style symbols, which is like, la-ti-da, we'll use these instead of strings wherever we want strings. So symbols are actually just unique values that can't be inspected. So when I run secret is equal to symbol, it creates a new symbol that I have no idea what it is, but it's a value, and the runtime will never expose it to me. But it is stored in secret. So I can use this variable secret to assign things. But we'll see what happens in a second. When we assign it into there, if we just print the object, nothing comes out because the key isn't knowable. But if we know the key, we can get something out of it. This is incredibly helpful for emitting objects and stuff that you don't want people to tamper with. Because that way you can have information being passed around that cannot neither be seen nor edited, unless you know the secret. Very fascinating. Run it again. Okay. We also get some data structures, which are awesome. Because people would say, like, okay, what data structures do you have in JavaScript? You have arrays and objects. And object literals you use kind of like maps most of the time. But we'll get to that in a second. So we are going to get an actual map type. So maps are like hash maps. they are hash maps, where you have keys and values, and you can insert a value with key, value. You can like inspect it to see whether it has things, delete things, get keys out of it. You're like, all right, that's kind of cool, I guess. But don't we already have object literals? Like they can do every single one of those things? And the answer is yes. The problem with that is, whenever you put something on an object literal, you're actually creating a variable. And you're not storing things as efficiently as you can, and it's a little muckier. Basically, dynamic data of this type belongs in a map. It doesn't belong actually in scope in an object. It may be nitpicky, but it's better. We also get sets, weak maps, and weak sets. Sets, obviously, you can add things to them and you don't get duplicates. But weak maps and weak sets will dispose of objects when there's no more references to them outside the map or the set. So it's kind of a cool way to, it basically cleans itself up and doesn't keep things around longer than it needs to. You also cannot not iterate over weak maps and weak sets because the keys are not stored per se. So I'm going to get into some game changers, some things that are really going to change the way you code JavaScript. These are the things we really wanted that people actually managed to get. Iterators and generators. These are splendid. So who knows what what's going to happen when I run this JavaScript? This is current JavaScript, ECMAScript 5.0. What am I going to get?
7, 8, 9.
Oh,
I don't think so.
wouldn't you just love it if we did? Sadly, we get 0, 1, 2. What's going on here is that the for-in operation iterates over the keys of an object. So an array is an object with the keys being the indexes. So we got the indexes 0, 1, and 2 out of there, which is really not what we wanted at all. So we have to tell JavaScript that no, you're doing this wrong. There used to be a problem in JavaScript as well where this would produce the functions on the object as well, though that's been cleaned up since, thankfully. So now in ECMAScript 6, we can now use the for of syntax. I'm using let there, but we could use var. It's just let is typically better now that we can use it. And this will give us exactly what you'd expect. 7, 8, 9. It seems like a small deal that the language is now doing what you'd expect, but for JavaScript, it's a step in the right direction. So, down. We also get generator functions. Those of you familiar with Python, it has things like this as well. Basically, there are functions that produce iterators that can be halted. So this is the new syntax for them. You have a function and then a star before the name, which looks like pointers, but it's not. And when you call it, you basically give it a function and it yields values. And then it'll pick up where it left off every time you ask for another value from it. So for example, when I run this down here, so I create an iterator out of the generator. So if you refer with, you have iterables, iterators, and generators. So they're all kind of separate. But an iterator can just be iterated through it next. So it's going to come through and it's going to get, okay, yield 0, and then it's going to wait until I call next again, and it's going to keep running and yield 1. So this is really helpful in that it, one, lets us express infinite values. For example, as you can see here, this would never end. I could keep asking for next and keep going higher and higher and higher and higher and higher, but that's okay because it doesn't have to evaluate all the time. It only evaluates when I ask for it, which is really cool. So you're saying, all right, that's all right, but it's still really annoying to have to use .next all the time. Thankfully, it works right alongside for of. So we can now actually iterate over a generator. So this will now log out our 0 and 1 that we 0, 1, 2, 3, 4 that we expect. Well, not 4. Iterate 2, 4. But yay, these are all very helpful things. Again, it's not that helpful on its own because typically you don't really want to you don't use generators that much. They're helpful, but typically you want to iterate over your own objects or something like that. We'll get to that in a second. Classes.
Real classes?
Real sort of classes.
Oh.
So, well, at its core, JavaScript is, ooh, whoa, that's spoilers. JavaScript is a prototypical language, which means you're actually dealing with object literals and a prototype chain. You're not dealing with actual classes and inheritance. But if you can realize that the way prototypical inheritance works, you can actually simulate object inheritance much better. Actually, entirely. You can simulate it entirely. Currently, in ECMAScript 5, this is how we write it. It's horrible. I create my class, using the function keyword. In here, I set this.I is equal to 4, so I'm setting an attribute, and I'm calling the super constructor. Cool. Let's keep going. If I then have to set my class prototype, which is what will be attached to all my instances when I run the function, to a duplicate of the parent's prototype to ensure that I don't corrupt the parent's prototype. Then I have to set the super manually, attach an instance method to this prototype thing, and attach a function to it like this. It's horrible. Also, you would notice that if I don't put the new keyword here, then the constructor won't work at all. So, this is bad, and we should feel bad for ever using this. But in Ecmascript 6, they've offered a better way to pretend you're not programming in JavaScript. So, you can actually define a constructor, you can define methods as per the object syntax we saw before, and it's all much, much cleaner. You can extend an object directly, you have access to super. It's great. This is just extending a basic object in this case. And we can run it, and it's going to log 4.
Wow.
Wow. Yeah.
Wow.
Right? 2014, guys, big year. Alright, so iterable classes is something that we've tried to do in JavaScript for a long time, and you really just couldn't do. There's no good way to iterate over a custom collection of any kind. Thankfully, combining basically everything we've seen so far, we can do it. Symbols, the symbol object, or the function actually, has an attribute.iterator, which is a known symbol. Rather, it's public, and no one knows the actual value of it, but we all have a reference to it. What that means is we can declare something as an iterator, and that way you'll never find it when you print the object. It'll never show up. You can't inspect it, really, but you can create it. And so it's a generator function where the key is symbol.iterator, and we just yield values out. Now we can do something really cool where we create an instance of our class and iterate over our instance. So, when we run it, we get 3, 14, 51, which is very exciting and exactly what we expected. I love it. So, modules. These are new. Let me say that again. Modules! Get excited! So, those of you who aren't really excited right now, you probably will explain. So, JavaScript in the browser. This is a scary thing. If we have these two script tags, I can declare I over here and log it here. They share a scope. There's a global scope in which everything acts, and that's it. That's all you get. Anything else you have to artificially create. And there are some ways around that people have built. But for the most part, everything shares a scope, which makes everything unsafe, everything dirty, and kills babies. So we don't want to do this anymore. So thankfully we don't have to. Module syntax. In JavaScript, you can declare modules with this. You declare a module, give it a name, and then you get your own scope inside of here. No one else can touch it. All they have is the name of your module in there. Now what's cool is this module can be declared inline. So like in a script I can declare a module with the name off. Or I can provide, for example, a URL route, and it will go and load it from there. So there's some really, really powerful stuff we can do with modules. Notice we export functions, because you have to export, or else you're almost useless. But, not here. Okay, so we're going to import, there's all different ways you can deal with modules. We can import, for example, how we'd import jQuery now, rather than having to like put an extra script tag. Basically, it keeps JavaScript separate from the browser, from the HTML, which is very nice. Different ways of importing, we see our fancy object destructuring there, more destructuring in fancier ways. Very cool. But we have this issue where people have wanted to do this for a very long time. And if there's one thing JavaScript developers know how to do, it's make something work that really shouldn't. So there's a couple standards that have arisen for handling modules. One is require.js, where you define modules like this. I have my dependencies, which are files, they're file paths, URLs. And then I take them in as a function and do this. If you can see, functions have their own scope, so we don't share any scope. The only thing that needs to be in our global is this define method, and it's actually pretty clean, but it requires a hell of a lot of work and setup. There's also common.js, which is used in Node, for example, for handling modules, which, again, is pretty good, but it suffers from some problems of, for example, I stop execution to go grab this module, which is bad. But they're both standards, and people use them a lot. And no one's going to use ECMAScript 6 modules if these already work with their projects, right? So how do we handle this? Module loaders. The loading of modules in ECMAScript 6 is configurable. You can create loaders that will be able to handle AMD, Require.js, and CommonJS, so that you can actually include them like you could any other ECMAScript 6 module, which is incredibly powerful. You can even write custom loaders for loading in, for example, templates as functions, like handlebar scripts and things like that. This is incredibly versatile and incredibly hard to understand in the draft spec. So what's going on here basically is that when you load a function, you have to give it a global syntax, a global object on which to run, some intrinsic functions and stuff that it'll know about. The mode it's interpreting in, strict versus non-strict, showed up in ECMAScript 5. Basically, it's a way the browser can like fail earlier rather than fail later. And then a whole bunch of hooks that the browser will use to interpret whatever module you're loading. Long story short, I could load my Require.js files like this, and everyone's really, really happy. So, that was really quick. So let's take a quick little trip down memory lane. Talk about syntactic sugar, fat arrow structuring, and better object literals. These will make life less charactery. Niceties, we got let and const showed up, so we can do some nicer variable typing and block scoping, literals and symbols. Lots of more data structures for holding all of our data beyond just an object literal. Iterators, generators, and classes, you'll be using these a lot, and especially modules. I like modules. So I guess, are there any questions? I kind of threw a bunch at you all at once. Yes?
I'm confused as to where this is in the map. Is this what JavaScript is eventually to become? Or?
Okay. Yeah, I use ECMAScript 6, ECMAScript and JavaScript interchangeably, which is more or less okay, but it's a bit confusing. This is going to be, the spec is supposed to be finalized in December of this year. Once the spec is finalized, I would give it like a couple months, like 2 months before it's entirely implemented, because as part of the draft process, you have to have at least a cursory implementation of everything in it, because what they do is they accept the draft and they say, okay, now does this actually work? Let's build some code and try it out and figure out our edge cases and things like that. So by early next year, you should have all these things in your browser of choice.
And that will be the new JavaScript.
So
that will be the new JavaScript.
Is that what happens with all new versions of JavaScript?
Yes.
So these are the people behind JavaScript, essentially.
Yeah. ECMA is actually more of just like mediating body. Mozilla and IE and Mozilla and Microsoft and Google are all in on that and helping make these decisions.
Cool.
Yeah, it's exciting. If you notice, also everything that we use in this presentation won't affect the behavior of anything in ECMAScript 4. All those weird things that it does and all the ways it does everything will not be touched, so all of your code will still work. You can just add more on top of it. It's a superset, so that's exciting. Yes.
If I can't wait and I want to do the newest, shiniest version you got going there, how do I get on that?
All right, so let's just hop back quickly to a place where I have runnable code. I had here. That's a big one, but whatever. So this is using Google's Traceur, Traceur, which is a compiler for ECMAScript 6 that compiles it down to ECMAScript 5. So in other words, I can write my new stuff, and it'll compile it down into functions that work now. The code it generates works.
That's it. It's janky.
It's also meant specifically to either be put on a page that's loaded, that scripts are loaded loaded remotely and compiled immediately, or for pre-compilation. I would say a significant amount of hacking, but more just a significant amount of reverse engineering to make it work for this presentation. There's really only like one function that does it, but it links into like 7 other things that are undocumented. So if you ever want to do something like this, this will be up on GitHub later. But otherwise, you just use Traceur, and it'll handle things for you.